Good morning, and it's time to put in practice what we learned from our previous lectures. So, we're going to be talking today, this morning, we're going to be talking about I/O. And let me get rid of this. I have to do a little bookkeeping here. Here we go. We're going to be doing LC3, that's an L3, LC3 I/O. And basically, we have two devices that we need to concern ourselves with. One of them is the keyboard, KBD, and the other one is the display, otherwise known as the monitor. And there are a couple of things you need to recall from the first thing that we talked about, the first video in this chapter. Each one of these devices is actually going to have two registers associated with. So one of them is going to be called the KBDR, okay, and that's the keyboard data register. And then there is going to be the KBSR, and that is the keyboard status register. And then likewise down here for the display, there is going to be the DDR, and that is the display data register. And then there is going to be the DSR, which is the display status register. Okay? So what we're going to do is we're going to break this up, look at each device individually. The first thing I want to remind you of is that the LC3 employs memory mapped to I/O. So what that means is that each one of these four registers is actually mapped to a physical memory address. And in the case of the keyboard, what is going to happen is we have the KBDR, and that is actually mapped to the address hex FE02. And then we have the keyboard status register, and that is mapped to FE00. And there are a couple of things that we need to note here. First of all, recall that memory addresses on the LC3 are 16 bits. So if we come over here and we consider what's happening at FE02, there are 16 bits over here. But what happens is when we strike a keystroke, its particular ASCII code is going to be stored in just half of it. It only needs half of it, 8 bits. So sometimes this is what's called the keyboard scan code. And again, each key has a different scan code associated with it. Very frequently, the scan code is the same as the ASCII code for it. So that means we're not using the left 8 most bits. Okay? And what's going to happen over here, the keyboard status register, again, it's 16 bits. And for now, the only thing we're going to be using is the leftmost bit right over here. This, for the moment, we'll say is unused, although a little later on we're going to use one more bit over here. And we're going to refer to this as the status bit. Okay? And basically what is going to happen is when the keyboard is hit, okay, what happens is the status is set to 1. Okay? And when the LC3 reads keyboard data register, okay, status is set to 0. Okay? So in other words, we hit a keystroke, this is set to 1. Okay, when the LC3 goes ahead and actually reads this thing gets set back to 0. Okay? So what happens is that when we want to read the keyboard, we basically are polling this bit. Okay? And remember what we said polling is. We just go into a very tight loop where we keep checking this bit. And as long as this bit is 0, there is no keystroke to read. Let's continue the discussion here. I was interrupted, so you'll excuse me. We'll come over here. We'll start with a clean sheet, again, just explaining the code for the LC3. Again, let me just draw some pictures here. So we have the keyboard status register, and the keyboard status register is at hex FE00. And remember, here's where the data would go. And then there is the keyboard data register. Keyboard data register. And that is at hex FE02. And we said over here, the leftmost bit is the status register. And I want to write the code for what would actually read the keyboard. So what I'm going to do is I'm going to do a couple of things down here. I'm going to come over here and I'm going to say keyboard status register fill, and that is hex FE00. Keyboard data register fill, and that's it FE02. And let's take a look at this code. And this code is right out of your book. So I'm going to stick a label up here, and I'm going to say start, and I'm going to do a load indirect. So we have to remember what that is. And let's write this part right here before we start analyzing it. And then we're going to do a branch 0p to start. Okay, so a couple of things to go on here. I don't know where this code that I'm writing, where it resides in memory, and it doesn't particularly matter. But notice over here I'm doing a load indirect R1. So what is true is remember that this has to be within 255 words of this. Okay, but we're referring to something that's potentially very far away. This is way in high order memory. So what this is doing is this is actually loading R1 with the memory location that's way down here at hex FE00. And if this doesn't make sense to you, you need to go back and review how load indirect works. But now we're taking this number here and we're actually loading it into R1. And then notice what we're doing here. If there were a 1 over here, okay, in the status then this whole thing, when we loaded register 1, that would set the negative flag. Remember 2's complement notation. If there's a 1 there, it's a negative number. We're saying branch on a 0 or a positive. That means there's a 0 here. And so I am basically staying in this very tight loop here as long as there is no key to read. Now remember, at some point if somebody presses a key, then this thing is going to be set to 1, and then I wouldn't execute this branch and I would come down to the next statement. Now at the next statement, what I'm going to do is I'm going to do an LDI. I'm going to say R0, and I'm going to say keyboard data register. So now what's happening over here, the data register, which is at hex FE02. Remember, when somebody hits a keystroke, the scan code for that key is contained over here. And that's now going to be read into R0. And at that point, I'm all done with this loop. And I would do a branch negative 0 positive to whatever it is that I want to do next. And I'm just going to call it next task. So this is a short little fragment over here for reading a keystroke in. Okay, I hope that's clear. Now what I'd like to do, I'm going to come over here, I'm going to save this, I'm going to clear that up, and I want to talk about the monitor now. Okay, another name for the monitor is the display. Okay, and remember what's going on over here. There is the display status register, and there is the display data register. And let us remember that the status register is at hex FE04, and this is at hex FE06. And remember, this is a status register, so the status bit is right here. Here's the status. The rest of this isn't used. Let's remember over here. Here's the byte that we want to display, so this isn't used. And the whole idea here is the following. We're going to keep looking at this bit over and over again. And as long as this bit is 0, that means that the monitor is busy and I can't display what's in here. Okay? But once this turns to a 1, then that means that that the monitor is no longer busy and I can actually go ahead and display that thing. So the idea here is the following. I'm going to come down here and I'm going to say DSR fill FE04, and I'm going to say device data register dot fill, okay, hex FE06, and again I'm going to come up here and I'm going to have some loop. So I'm going to say start, and I'm going to say LDI. This is very similar to the last code that we wrote, R1, and I want to get the device status register, DSR. And I'm saying as long as this thing is 0, or as long as it's not 1, I'm going to say branch on 0 or positive to start. Okay, that means that this thing, that means that the monitor is busy. It's busy doing something. It's busy displaying the last character that we got it. Now, when the monitor is not busy anymore, when it's all done displaying the last character, it'll change this bit to 1. And when this bit becomes 1, we're going to come down here. What is it that we want to do here? Well, what we want to do here now is we want to move a char to display to the data register, the DDR. Okay, the display data register. So what I would do over here in this loop right here is I would say STI R0 DDR. So the assumption is here, we assume that R0 contains character we want to display. So what we do over here is we just do an STI R0 to DDR, okay? And at that point we go ahead and it's getting displayed, and then we do an unconditional branch, -0, positive, to next task, whatever that is. Okay? So the whole idea here, again, it's very similar to what we saw on the keyboard, is the idea that we keep polling a particular bit. Okay, and as long as it is 0, that means that we're not ready to do anything. Once it becomes a 1, we fall down to here, and that indicates that we're able to process the I/O request. Greetings again. I had to stop the machine. Now we go ahead and continue. We're going to finish up this chapter. And I'm going to take the code right out of the book here. This is right at the end of the chapter here. And I just want to review what they've done here. And what they're doing over here is they want to do, let me see where my cursor is. There it is. They want to do character, actually I want to say keyboard input with echo. Okay, and they actually also, they want to print a prompt. So something like, enter a character. It's going to print something like that out, and then you type in the letter A, and maybe you hit the carriage return. So you'll note this looks very much like a trap that we have. I don't remember which trap it is, but you can look that up. Anyway, let's come over here and look at the particular code. And there are a lot of things to note about this code here. And we're going to recognize most of this stuff, but some of this stuff is different. First of all, one of the things that we're going to note about this code over here is that it's going to use a lot of registers. And this application here where we ask the user to enter a character and get something, that is something that we might want to use a lot in our program. But this thing is using a whole lot of registers here that may have been used in other parts of our program. So this is the beginning of something new for us. And you'll notice that when you come down here, okay, here's where the space is allocated for our data. You can see that there are three spots in memory here called save R1, save R2, and save R3. These all have block word declarations of 1, which means that these are each occupying 1 word of memory. But you can see, and what I want you to note very carefully is these 3 lines of code right here, okay? And then I want you to note these 3 lines of code right over here, down here. Here what we're doing is, you see the code in the middle is going to use registers R1, R2, and R3. So what we want to do is whatever values they currently have, we want to save them. Okay, so we've allocated space to save them. And notice the very first 3 lines of code here are saving the registers. And you'll notice right over here, the very last 3 lines of code, again, the very last line of code is just to do an unconditional branch to another task. But you can see here that we're restoring the values. So you can see here, we're saving the registers. Down here, we're restoring the registers. That's a very important concept, and you should look at these 6 lines of code just to make sure that you understand what's going on. Now, a couple of other interesting things that are going on here. Over here, you can see that we're loading R2 with new line. And you come down here and we can see that new line has an ASCII value of 10. That's actually on most Linux and Unix systems. That's how you do a carriage return. That's how you get the cursor to advance to the next line. So you can see that what's going on over here, first of all, here's a loop right here, where it appears that what we're doing is we're checking the status. We're checking the status bit in the display status register. Notice that DSR, okay, is the value of the display status register. And notice what we're doing over here. It's a load indirect. We're branching on 0 positive, which means that we stay in this very tight loop as long as that status bit is 0. Once it gets set to 1, we move down to here. Well, what are we doing over here? Over here, we're taking that new line character, which was stored in R2, and now we're displaying it. What you're doing here is you're now making the cursor go down one line on the display. Then you'll notice over here, here's an LEA R1 prompt. And you come down here, prompt, and I guess I should move this over a little bit here. And you can see that the prompt is a string Z, and it says input a character. Okay? Remember, string Z means that each one of these characters is occupying one word of memory, and then it's terminated by a 0. And I'm going to move this over again because I don't want to be bothered by the comments in the book. You can go back and look at those. But you can see over here that I'm loading R1. This is the address of where the prompt is. And then what I'm doing over here, you can see that this is going to be a loop here where I am going to output the string. So let's see if we can figure out what's going on over here. So the first thing we're doing is we're taking, you can see over here, this is doing base offset addressing. We're getting the first character and we're loading it into R0, and we're saying branch on 0 to input. So in other words, as long as we're not looking at 0 at a null terminated string, we have some positive value here. So here you should recognize we're polling the display status register again, okay, to see if it can take another character. We would fall down to here when we're able to display it, and it would display the first character. Then we're adding one to R0. So in other words, what's going on over here is here in memory, this is very, very clever what's going on, and I'm just going to pretend that we have A, B, C here, and then over here, it's null terminated. Okay, maybe this is prompt. So if I came over here and I were to say prompt, and I were to say string Z, and then come over here and say something like ABC. This is what would happen. I would have an ABC loaded in there like that. Over here, I'm doing an LEA of R1 of prompt. So maybe prompt, I have no idea where this is. Maybe this is at hex 3100. So now what happens is I've got an R1 contains 3100. And what's happening over here is very clever. I'm saying load into R0, R1 plus 0. So now what I'm saying here is that R0 gets memory of 3100 plus 0, okay, which in this case is an A. So I'm just going to write over here an A. So R0 got an A, okay, and that is happening over here. And we're saying branch on 0 to input. Well, it's not 0. So now you can see over here we're getting ready to display it, and over here we actually display it. So I'm going to say we're going to display the A. And then look at what we do here. We add 1 to R1. So R1 now becomes, I get to use my nifty graphics tool over here. It now becomes 3101. And after it becomes 3101, we say branch unconditionally back to loop. So with loop, I'm now going to load R0 with what R1 is pointing at. Well, R1 is now pointing at the B, so R0 is now going to get memory of 3100 plus 1, and that's a B. Then over here, we go into this loop until the display is ready. We just loop here. Now the display is ready. We're going to go ahead and display it. We're going to display a B. Okay. And then you can see after we display the B, we add 1 to R0. So now R1, and now R1 becomes 3102. So you can see that this loop keeps continuing and it keeps outputting until I actually load a 0 in there. So what's going to happen on the screen here If this were my string, it would output an ABC. But of course, the actual string is input a character, so what I would really see on the screen is input a character like that. So this whole loop right over here is outputting the string input a character. Now we're ready to get the input. So here you can see we're looking at the keyboard status register, and we keep branching in here until there's a keyboard to read. Once I come down to here, that means there is a keystroke to read, and I'm actually loading it into R0. Okay, and then you can see what's going over here is now I'm polling the display register until the display is ready, and then whatever keystroke was stored in R0 is now going to be displayed on the screen. So this whole thing right over here, this is the echo. Okay, so we printed a new line character, we printed the prompt. Over here, we got a keystroke. Over here, okay, what we did actually down all the way down into here is here we displayed the character. Does that make sense? Okay, very good. Then let's see what is happening down over here. Over here, it looks like we are loading R3 with DSR, the status register. We're polling here. Then over here, we are storing R2. What is R2? Oh, R2 has the new line character. So what's happening is after we've displayed the character that the person typed, we're skipping down a line. Then finally what we're doing is we're restoring the 3 registers again, and then we branch on to the next task. This is a very worthwhile exercise or a piece of code for you all to study.